Okay, well, welcome back to the final video for the Honors Pre-Calculus Marking Period 3 RQA Review number 1. We're going to go ahead and finish off with problems number 8 and 9. Okay, so number 8 says, Mr. Gruber and Mr. Steitler are practicing their soccer skills after school one day. Mr. Gruber is standing 51 feet from Mr. Steitler. Mr. Steitler kicks the ball from the ground at an initial speed of 45 feet per second at an angle of 60 degrees with the ground. Assuming no air resistance, find the height of the ball when it reaches Mr. Gruber. Your answer should be corrected 3 places after the decimal. So I'm just going to go ahead and kind of draw a little scenario of what we have here. So if we put this on a coordinate plane, right, with x's and y's, we have that Mr. Steitler is, we'll draw him right here, okay, is kicking a soccer ball to Mr. Gruber or myself. So I am over here, we'll say this is S for Steitler, and we'll put me over here as G for Mr. Gruber. So he's kicking this ball from the ground to me, right, at an angle of, it says 60 degrees with the ground. Notice that the initial height here is 0, right? They assume it's 0, they say it's from the ground. And it's going at a speed of 45 feet per second. Okay, that's going to be our initial velocity. And they also tell us that I am standing 51 feet from Mr. Steitler, right? So we're supposed to find what's the height of the ball here, right, when it reaches myself. That's the question we're trying to answer, okay? So to do this, we're going to use the projectile motion equations for parametric equations. So those are the ones that look like this. We have x of t is the initial velocity times cosine of the angle theta times the time, and the height is equal to negative 16 t squared plus the initial velocity times sine of the angle theta times t plus the initial height. Right? So here we have, if we label it with the values we're given, they tell us that the initial speed is 45 feet per second. They tell us that the angle theta is 60 degrees. Again, you can look at the picture I've drawn up here to get all this information as well. And they tell us that the initial height is actually 0 because it says Mr. Steitler kicks the ball from the ground. Right, and then t is going to be kind of what we're looking for here to help us answer the question of how high is the ball when it reaches me, right? So thinking about the pieces of information they've given us, let's just go ahead and write the updated equations using this information. So our actual equation, this is all info we need to use, right? But our actual equations are x of t equals initial speed or initial velocity of 45 feet per second times cosine of the angle 60 degrees times t, and y of t equal to negative 16 t squared plus 45 sine of 60 degrees times t, and then plus 0, but you don't necessarily have to write the plus 0, right? That doesn't change anything. So those are our equations. So what I want to do here is, in order to find out the height that the ball is at when it reaches me, I need to somehow find the time it takes for the ball to reach me, first of all, right? Because both of these equations are dependent on time, so I can't answer anything until I know the time that I'm interested in that. So what I can do is, I do know that I am 51 feet from Mr. Steitler, so I'm actually going to set x of t equal to 51. Okay, so in other words, I'm using this top equation, and I'm going to set that equal to the x equation. Okay, so essentially what I'm doing is I'm trying to find the t value that makes this equation equal to 51. Right, so I know that I'm 51 feet away, that's an x value, so I replace this with 51, and I know the equation for x, so I set that equal to 51, and I'm trying to find t. Right? If I can find the time it takes to reach 51 feet, in other words, to reach myself, then I can take that t value I find and put it into t for the y equation, which will give me the height at that specific time, answering the question that I was asked. Okay, so I'm going to show you guys some images that I've taken of when I use the calculator to do this. So the first step is I'm going to go to y equals, and for y1 I'm going to put 51, right? That's the left side of this equation, and the right side I'm going to put the x equation. Now notice that it says x and not t. We have to remember that since we're in function mode in our calculator that this is actually a time, right? So the way that the calculator solves an equation like this is it finds where does the graph of this and this intersect, right? So I put it in y1, y2, okay? They also give us this calculator hint of setting our window to an x min of 0, an x max of 5, a y min of 0, and a y max of 60, okay? So to do that, you're going to go to the screen that looks like this. You're going to make your x min 0, your x max 5. The window button can be found right next to the y equals button in the top left corner of the calculator. And the only other things I'm going to change are y min 0, y max 60. Okay. I'm going to go ahead and graph that. Okay, and your graph should look something like this, right? So this is your height of 51. This is your x equation. We're trying to find this intersection point. I'm going to tell you how I did this in a second. So where does this line intersect this line, which essentially is just solving this equation, right? So what value of t, or as our calculator is saying, x, makes this equation true, right? So I have the graph. I need to find this intersection point. The way I do that is I go to second trace after I've graphed it with my window set up, and I go all the way down to option 5 and choose intersect. Okay. It's going to ask for a first curve question mark. It'll either be this one or this one depending on how your calculator is set up. So if it said first curve question mark, it's asking me, do I want this to be my first curve that I'm going to look at to try and intersect with a second curve I'll pick in a second. So I'm going to say first curve. I'm going to move the cursor as close as I can to the intersection but not right on top. Hit enter. That's a command for yes. Then it'll say the same thing but second curve. I'll do the same process. I'll move the cursor pretty close to the intersection but not on top. Hit enter. Then it'll say guess question mark. That means do you want me to approximate this intersection point? So when it says guess down here, we'll say enter. And this is the result that you should get roughly. It may not be exact just because of where you choose to put your cursor, but it should be 2.2 something, right? So this here, remember x is a time value in this case. So this is telling me that at 2.267 seconds, we'll say, the ball reaches, I know this says y, but it reaches 51 feet, right? So I need to use 2.267 seconds and go back to my y equation and plug that in here and here, and that'll give me the height when it reaches 51 feet, or in other words, myself. So I'm going to do that on this last page. Let's see what we get. So we're going to say y of 2.267 seconds is equal to negative 16 times t, or 2.267 seconds squared, plus 45 sine of the angle was 60 degrees times the time, 2.267, right? And if we do all this in our calculator, we find that the ball is 6.119 feet in the air when it reaches Mr. Gruber, which is the answer they were asking about, or the question they were asking about. Okay, so that is problem number 8. That's pretty calculator intensive, but as long as you kind of follow that process, you should be able to get the right answer. Okay, let's go ahead and continue with the final problem of the review, number 9. So number 9 says the position of a robot moving along a curve in the xy plane is given by the vector valued function f of t is equal to the 5th root of 4t as the first component and t squared minus t cubed as the second component. So remember, a vector valued function is exactly that. It's a vector, so we have components here that each component is made up of its own function, which in this case is in terms of the parameter t. Okay, so they say write the rectangular form, in other words, an equation involving just x and y of the curve. So the way I'm going to do that is I'm just going to eliminate the parameter here. So the way that we approach that from the beginning is, well, remember that this is the x component, so I'm going to say x is equal to the fifth root of 4t, okay, and then the y component is equal to t squared minus t cubed, right? We're getting rid of or eliminating the parameter. So here, let me just separate this. I'm going to solve this equation for t first, right? This is always the process you use for eliminating the parameter. So I'm going to raise both sides to the fifth power to get rid of that fifth root, and then divide by 4. So I have t is equal to x to the fifth over 4, right? Now, to finish this up here, I'm going to take this, let me choose a different color. I'm going to take this as my t value, right? And I'm going to substitute this into this t value, and in this case also this t value, right? There's two t values. Both I'm going to replace with x to the fifth over 4. Okay, so we have now y is equal to t squared minus t cubed, where again t is now x to the fifth over 4. We just found this, x to the fifth over 4. Okay, so in the end we have y is x to the fifth squared. Remember your power rules. So power to a power, you multiply, so this is x to the 10th, and then 4 squared is 16. Same thing here, 5 to the 3rd, we multiply, so x to the 15 over 4 cubed is 64, right? Now we could get this into a common denominator, but this is good enough. We've done our job. We've gotten it into an equation just involving x and y, in other words, rectangular form. Okay, and we can go ahead and say that's our answer because we've eliminated the parameter t. Okay, so I hope you found these videos helpful. That is the end of the Honors Pre-Calculus Marking Period 3 RQA review number 1. And good luck on the test, and thanks for watching.